Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will try to discuss a very important topic, mainly how we can easily estimate the lake area using GIS and remote sensing technique. So I will try to show you that all of details from beginners to advanced level, how we can easily estimate the lake area using GIS and remote sensing technique in Google Earth Engine. So let's go, I will try to show you that. So first of all, I simply choose my study area. So this is my study area. So this area, I want to monitor the lake area. So here we find out that two lake, upper Red Lake and lower Red Lake. So both of lake, I want to estimate how much area. So there's a lot of way. If you check some scientific paper, they use the different technique to identify lake area using GIS and remote sensing technique. So I'll try to show you that. So first of all, you need to choose your satellite images. So in this case, if you want, you can use here the Landsat, or if you want, you can also use here the Sentinel to satellite imagery. So but when you work with past time or past decade, then you try to use here the Landsat satellite imagery. But when you work for the current situation, because it's very update situation or real time, then you try to use here the Sentinel-2, because Sentinel-2 is very high resolution than Landsat satellite imagery. So in this case, I want to use here the Sentinel-2 satellite imagery. So just click on the browse data catalog and then open the Sentinel. So here I find out all of Sentinel image collection. So I choose the Sentinel-2 multispectral instrument. So here I find out that surface reflectance and top atmospheric reflectance. So I choose the surface reflectance satellite imagery. So here I find out this is my image collection. So this image collection I simply import in my code editor. So just I simply import in my code editor and then give a variable name. So I put the name, suppose image collection. Okay, so you can put any name as a variable. So now I simply imported my image collection, as well as I also imported the geometry, my shapefile geometry I take. So now then I simply put my time period. Suppose I just take a variable, I put the time start. Suppose I put the time start in year of suppose year of 2018, and take the another variable, suppose time int, and I put the variable name, suppose year of, and if you check the last time is that year of 2025. So I take suppose year of 2024. Okay, or if you want, you can also take the only for the single year 2020 or 90, 40 or 23, 22, 21. Okay, so you can also take the time period, but in this case I want to take the time period from year of 2018 to 2024. So between these years, all of years, I want to check the lake area. So now after that we simply filter our image collection. So for that same process, just take a variable, I put the variable name, suppose Sentinel 2, you can put any name, and then I call my image collection. So this variable is stored my image collection. So now I just simply filter. So how I can filter? I want to filter bounds with my study area, which is geometry, and then put the filter date. So I want to filter according to my time period, time start year of 2018 to time int year of 2024. Okay, just I simply stored the different variable, and then I choose my cloud level. So just I filter and put the ee dot filter dot less than. So less than, I put here that image properties. So I choose cloud pixel percentage, and assign the value, suppose less than 1. Okay, so just simply filter image properties. And now if you want, suppose between this time 2018 to 2024, you want to work only for the rainy season or only for the work for a specific month, or a specific season between this time period, not need all of month. Suppose year of 2018 to 2024, between these years I need only for the summer season, or I need only for the rainy season, okay, or any specific time period between these years 2018 to 2024. So if you want, if you want, you can also filter it. So for that you can simply use a function, it's called the calendar range function. Okay, so filtering a specific season or a specific month. So for that, just use here filter and put here ee dot filter dot calendar range. So this function, and put your time. Suppose I want to work for June to October, or I want to work for January to, suppose, January to April. So you can simply put the month number. Suppose in this case I put here that June, October. Okay, I put this time, and then also put the unit. I put the unit, suppose month. So now what happened? So now between this year 2018 to 2024, I just work only for this month 6 to 10, mainly June to October. Okay, June to October I take only for this between this year. So you can put the any time period or any season using this way. So now if you check how many images are available between this time for our study area, because sometime there is no image. So first of all we try to check how many images are available between this condition. So just type user size and run the code. So now it's computing. We find out the 59 images are available for our study area between this time period 6 to 10 month between this time. Okay, let's go. So now I want to compute the indices. It's called the different types of indices. If you check this paper, they use the MNNDWI, mainly modified normalized difference water index. They are used. Some paper also use the NDWI. Some paper also use the water ratio index. So you can use any one. There is no problem. Okay. So in this case, I just try to use here NDWI, normalized difference water index. And before that, when you apply the NDWI, we need to reproject the scale value. So if you check it, it show the this type of value. Okay, and it also provide the scale value. So this scale I need to multiply with my all of bands. So b1 to b7, all of bands we simply multiply, and then we compute the normalized difference for NDWI. Okay, so let's go and try to do it. So for that, if you want, you can also do it in here. Just write a function and do it. So for that, just create a function and put the element name img, and then just put our curly bracket. In this curly bracket, we simply put our argument. So my argument is that I want to multiply all of bands with our scale, and then also calculate the NDWI. So for that, take a variable, suppose bands, and call the element name img, and select all of bands. Basically in this time we have this type of band b1 to b7. I just simply choose. So let's go, simply choose my specific band. So b1, then b2, b3, b4, b5, b6, b7, b8, b8a, and further I simply choose b11 and b12. Or not need all of bands, then simply skip these things. b12. Okay, so as I simply choose this type of band. Okay, so after choosing this type of bands, we need to multiply with our scale value. So just I put here dot multiply, and multiply with 0.0001. So this is my scale value. Okay, to multiply all of bands, I just simply put in here. After that, we simply compute normalized difference. So just take a variable, suppose ndwi, and then I just call my bands, basically this variable bands. It stored all of those, and then computed the normalized difference, between two band. So near infrared band, near green band basically B3, and put at the near infrared band. Near infrared band basically it's a B8. Okay, so I put at the B3 and B8, and then just use here the dot rename function, and I put the name, it's a ndwi. Okay. So now what I return from here, so just I put here the return function. So return ndwi and copy properties this element image, and also copy properties of image property. So just put here the property names. Okay, property names function. Okay, and finally we create the median, and before that we simply connect this function. This function is simply connect with our image collection. So for that, just use here the dot map function and close the bracket, and now create the median. Okay, so now it's worked, and now we just try to visualize our imagery and also visualize the ndwi map. Okay, so let's go. So for that, just take a variable, just add mem.add layer, and then call the sentinel2, and these things just clip with my study area, which is geometry. I put the name. So now run the code. Okay, it's not work because it's work only for the collection. Just run the code. So you find out this type of imagery. So if you check, we find out this is the water body and this is the non-water body. We find out. Okay. If you want, you can also use here any types of other classes. So it show the ndwi. If you want, you can also add the color. Okay, suppose I just put here different types of color or spacing, and add the different types of color to visualize the ndwi map more better. Suppose I put here this type of color. Where there is no water, it show this type of red color, and where is water, it show this type of blue color. I put only for the two color, and I put it the custom. Okay, and now apply. So now you find out this type of map. So here we find out this type of blue color. It's indicating about that water body. Okay, so this is the water body. So just I simply import the visualization and copy and paste after the object name, and put the layer name. I put the layer, you can put any name as a layer. I put the layer name, suppose ndwi. Okay, so now from this ndwi, I just choose only for the greater than 0 all of pixel, which is indicating only for the water body. So just I apply here, and then just use a function. It's called the gt function. Gt mainly greater than. So just I put the gt and put here the 0. Okay, 0 means I take only for this pixel. This is the greater than 0, and I add it later. Okay, add the visualization later. I put it's a water. Okay, now check the result. Okay, so we find out this type of binary class. So basically this layer, water layer, we find out. So this type of white color, it's indicating about that water body, and this type of black color, dark color, it's indicating about the non-water body. Okay. So after that, we just choose the threshold value greater than 0, and now we find out this type of map. So now this thing we simply marks with our imagery. So for that, just I take a variable, suppose threshold, and then just call the sentinel2. From here I just choose greater than 0. Okay, or if you want, you can also calculate this threshold value using oddshow, but in this time I will not show you this process. For the tutorial, inshallah, I'll show you that how we can easily apply the oddshow method to find out that threshold value. So now this thing I simply update max with that. So for that, take a variable, suppose max, and then call this threshold. I just use and then update max using this threshold value. So now I find out the one layer max. So now we try to display it as a layer. So just put here map dot add layer and call the max and run the code. So now you find out only for this max layer. So now it display only for this water body. Okay, on our lake we find out. Okay, so when I just update max, I put the greater than 0. But if you check, we can get some others water body pixel in here. So for that, if you want, you can also increasing 0.1 or 0.2, then try to check. Or if you want, you can also calculate the oddshow method to identify for separation using the best threshold value. So in this case, I just keep this type of way. So I find out this type of things, and now I want to calculate the pixel area. Okay, so pixel area, mainly how much pixel area we find out the water body. We just simply calculate the pixel area. So for calculating the pixel area for the max layer, so just we take a variable. Suppose I put the variable name is that pixel area, and then call the max. So these things I want to apply a function. So basically I just put the multiply function, multiply with the ee dot image dot pixel area. So this function basically compute the pixel area and generate an image. Okay, generate an image. So just I apply it, and it calculate the pixel area in square meter. So just I simply divide with 1 is 6, then it compute the result in a square kilometer. We find out the result. So if you want, you can also display the pixel area, and further we try to calculate. So just map dot add layer and call the pixel area, and further clip with our study area, which is ROI, and now run the code. So now it show, sorry, it's a geometry. So now run the code. So now it's work. So now you find out that NDWI pixel area layer. Okay, so this is the NDWI pixel area layer we find out. So now we just try to compute using a function reduce region. Okay, so compute this type of pixel area, total pixel area we try to compute. So for that, take a variable. I put the variable name is that suppose area, and now apply this call the pixel area and apply a function reduce region. So just apply the reduce region and put all of argument. So first argument is that reducer. So I need to compute the total area. So you apply ee dot reducer dot sum. So now it's compute the total area, And then put second argument is that geometry basically same. I put the geometry, it's my boundary shape file. And then scale is the resolution of your satellite imagery. I put the 10-meter resolution. Okay, and now further I just simply print and then check what happened this area. Just print and run the code. So now it's create a dictionary and compute. So we find out this type of problem. So it's a common problem. It shows the too many pixel in this region. So for that, if you want, you can also apply the function max pixel function. You can also apply max pixel and then check what happened. So just apply the max pixel. I put the 1e13 and now run the code. So now I hope it will be work to compute the total pixel area. So it's working now. We find out this type of area if you check. So this is the total lake area. So we find out that 1144.01 square kilometer unit. We find out the total area of this lake. So I hope this tutorial is also help you to compute the lake area. Further, I also discuss about the another interesting topic. Then I hope you can also get the new idea from my YouTube channel. So in the meantime, I also give you an announcement for our upcoming online training program. So basically, every month we arrange this online training program. And this training program, if you have no knowledge about the Google Earth Engine or if you have no knowledge about the coding, so we try to teach you all of those from beginners to advanced level on Google Earth Engine. And if you don't know knowledge about the coding, mainly Python or JavaScript, don't worry about that. I hope after completing this full total 7 days online training program, you are able to do any types of image analysis very quickly and efficiently. So if you check all of course content for our upcoming online training program, so it will be start from that next week, 25 July. So if you're interested to join, then simply contact in this WhatsApp and also contact with this email. Further, simply complete your registration and then join our online training program. So you can also get some benefit. So when you join our online training program, you can get course certificate. You can also get all of materials, mainly slide or PDF. You can get all of practice code. You can get all of recorded session. And you also get the lifetime listening support. Basically, as a beginner, so when you start the journey with cloud computing or programming based GIS remote sensing, you face a lot of problems. So that's why we also give you the lifetime teaching support regarding this online training program after completing this live session. And I also get the research collaboration. So if you want to publish any scientific paper regarding this type of topic, so you can also get it. So you can simply check all of details for our upcoming online training program. Then you can simply join, and further you can easily do a lot of remote sensing and GIS analysis. So today is no more. Thank you for watching that. Stay happy, stay safe.